Hello, friend. I am Neil Tyson, and tonight I will be your guide. I invite you to join me on a journey far beyond the familiar blue sky, beyond the noise and the weight of the waking world. Allow yourself to settle in, to feel the gentle pull of gravity on your body, a silent reminder of your connection to this beautiful earth. But for now, let us release that connection, just for a little while. Feel the anchor of your day begin to loosen, the tension in your shoulders and your back slowly dissolving. Imagine the force that holds you here is becoming lighter, softer, until it is nothing more than a gentle suggestion. You are beginning to float, drifting upward, past the ceiling, past the roof, ascending into the cool, still air of the night. Below you, the world becomes a soft tapestry of lights, a quiet map of sleeping towns and dreaming cities. The sounds of the day have faded into a low, distant hum, and then into perfect silence. You are rising higher now, through the thin, wispy veils of the upper atmosphere, where the air grows clear and the darkness deepens. The curve of the earth becomes visible, a brilliant blue and white crescent hanging in the void. There is no wind here, no weather, only a profound stillness that surrounds you like a comforting blanket. This is the observatory of the mind, a place of perfect peace, from which we can witness the grandest story ever told. Here, in the silent theater of space, we turn our gaze outward, toward the faint, shimmering clouds that drift between the stars. These are the nebula, the cosmic dust lanes, the very places where the universe is built. They are not empty spaces, but vast, rich reservoirs of potential, holding the raw ingredients for future suns, future worlds, and perhaps future life. Tonight, we will drift through these celestial wonders, exploring the quiet facts of their existence. There is no need to hurry. There is nothing to solve, nothing to achieve. Simply allow your mind to drift with my voice as we journey together into the heart of the starlight and explore the deep, restful truths of the cosmos. We begin our journey in the seemingly empty space between the stars. This vast, dark ocean is not a true void. It is filled with an almost invisible substance, a fine, ethereal mist known as cosmic dust. Our first fact is a gentle reimagining of what we call dust. Here on Earth, dust is often seen as a nuisance, a collection of forgotten particles in quiet corners. But in space, cosmic dust is treasure. It is not made of skin cells or fabric fibers, but of microscopic grains of carbon, silicon, oxygen, and iron. These are the fundamental building blocks of planets, the seeds from which worlds like our own are born. Think of it as the universe's fertile soil, scattered on the grandest of scales. Each grain is a tiny piece of a star that lived and expired long ago, a microscopic messenger carrying the story of cosmic history. This leads us to our second fact. These dust grains are incredibly small. A typical particle of cosmic dust is just a few molecules to less than a micron in size. To imagine this, picture a single grain of sand. You would need to line up over 100 cosmic dust particles end to end just to match its width. They are smaller than the wavelength of visible light, which is why they are so difficult to see directly. They are like motes of dust in a sunbeam, but the sunbeam is a distant star, and the room is the entire galaxy. Third, this cosmic dust is often coated in a delicate layer of ice. In the deep, cold vacuum of interstellar space, temperatures plummet to hundreds of degrees below zero. At these frigid temperatures, molecules of water, methane, and ammonia freeze directly onto the surface of the dust grains, creating a frosty shell. Imagine trillions upon trillions of these tiny ice-covered specks drifting silently through the void. They are like microscopic snow crystals, each one unique, each one a tiny frozen world in its own right, waiting for the warmth of a new star to awaken it. Fourth, despite its sparse nature, cosmic dust has a profound effect on light. The sheer volume of these particles scattered across light years of space creates a phenomenon called interstellar reddening. This is our fourth fact. Just as the Earth's atmosphere scatters blue light to create a red sunset, these dust clouds scatter the blue light from distant stars more effectively than red light. As a result, the starlight that passes through them emerges on the other side appearing redder and dimmer than it truly is. So, when you see a particularly red-hued star in a telescope image, you might be looking through a veil of ancient cosmic dust, a silent filter painting the cosmos. Our fifth fact is about the origin of these precious grains. Where does all this dust come from? The primary source is dying stars. Stars like our Sun, in their final phases, will gently puff their outer layers into space, creating beautiful planetary nebulas. In the cooling atmosphere of these aging stars, elements like carbon condense into solid grains, much like soot forming in a flame. More massive stars end their lives in spectacular supernova explosions, forging heavier elements like silicon and iron and blasting them out into the galaxy. Cosmic dust is, quite literally, the ash and smoke of expired stars. This brings us to our sixth fact, a poetic nickname given to this substance by astronomers, the smoke of the universe. It's a fitting description. Like smoke, it is born of fire. Like smoke, it obscures the view, hiding vast regions of our galaxy from our sight. And like smoke, it eventually clears, or rather, it coalesces, gathering together under the patient hand of gravity to form something new. It is the end of one story and the beginning of another. Let us consider the texture of this dust, which is our seventh fact. Scientists have discovered that some cosmic dust grains are carbon-based and have a crystalline structure. They are, in essence, microscopic diamonds and graphite particles. Imagine floating through a gentle, glittering mist, not of water, but of diamond dust. Each tiny crystal catches the light of a far-off star, scattering it into a soft, ethereal glow. This isn't just a fantasy. Our galaxy is seeded with these tiny, precious gems, drifting through the dark. Our eighth fact speaks to the sheer quantity of this material. While the space between stars is an almost perfect vacuum, the total mass of cosmic dust in our Milky Way galaxy is immense. It is estimated to be equivalent to about 100 million times the mass of our Sun. If you could gather all of it together, you would have a colossal cloud of raw material, enough to build billions of new solar systems. It is a quiet, hidden reservoir of creation. Ninth, not all cosmic dust is the same. Just as our planet has different types of soil and rock, the composition of cosmic dust varies depending on where it formed. Dust from carbon-rich stars has a different chemical signature than dust from oxygen-rich stars. By analyzing the light that interacts with this dust, astronomers can act like cosmic archaeologists, learning about the types of stars that populated a region of the galaxy millions or even billions of years ago. Each cloud tells a different story of its stellar ancestors. Our 10th fact is about the role dust plays in protecting the building blocks of life. The dense clouds of gas and dust act as a shield, protecting the delicate molecules within from the harsh ultraviolet radiation of nearby stars. This radiation would otherwise break these molecules apart. Inside these dusty cocoons, complex organic molecules, the very same types that form the basis of life on Earth, can survive and grow. These clouds are not just hiding stars, they are cosmic sanctuaries. 11th, cosmic dust is not static. It is in constant, slow motion, swept up by stellar winds and shock waves from supernovas. It drifts in gentle currents through the galactic arms, swirling and eddying over millions of years. This constant churning and mixing enriches the galaxy, distributing the heavy elements created by one generation of stars to the next. It is a grand, silent cycle of cosmic recycling. And for our 12th fact about this fabric of the void, it is the dust that makes the beautiful nebulas we admire visible. Without dust, we would not see the brilliant blue glow of a reflection nebula, or the dark, stark silhouette of an absorption nebula. The dust is the canvas and the pigment. It catches the light, it blocks the light, and it transforms the light, turning invisible gas into the breathtaking cosmic art that fills our telescopes and our dreams. It is the dust that gives the void its texture, its depth, and its profound quiet beauty. Now let us drift away from the diffuse, glittering mist and move towards regions where this cosmic dust is gathering, pulled together by the gentlest, most patient force in the universe. We are entering the great stellar nurseries, the birthplaces of stars. Our 13th fact is that stars are born from the coldest, densest regions of space. It is a beautiful paradox. The most brilliant and fiery objects in the universe begin their lives in near absolute darkness and cold. Within vast molecular clouds, where temperatures are just a few degrees above absolute zero, gravity can finally overcome the slight pressure of the gas. A region begins to collapse under its own weight, pulling more and more dust and gas inward in a slow, inexorable spiral. Let us journey to one of the most famous of these nurseries, the Orion Nebula, a place we can even glimpse with the unaided eye on a clear winter night. Our 14th fact is about its appearance up close. If we could float within its luminous clouds, we would not see a static picture. We would be surrounded by a swirling, three-dimensional landscape of glowing gas, sculpted by the fierce radiation of the young stars already born within it. Vast sheets of pink and red hydrogen gas would billow around us, while darker, denser filaments of dust would snake through the scene like cosmic rivers. It is a place of immense and active creation. Inside this magnificent cloud, we find our 15th fact. The birth of a star is a slow and gentle process. It can take millions of years for a collapsing core of gas and dust to become a protostar. Imagine a cloud 100 times the size of our solar system, slowly, gracefully, spinning faster as it contracts. It's like watching a celestial ice skater pulling in their arms to spin, but on a timescale that defies human comprehension. The process is not a violent explosion, but a quiet, persistent gathering. Our 16th fact concerns the heart of this process, the formation of an accretion disk. As the protostar at the center grows more massive, the infalling dust and gas flatten into a spinning disk around its equator. This disk is like a cosmic potter's wheel, feeding material onto the growing star. If we were to witness this, we would see a dark, opaque disk, perhaps miles thick and billions of miles across, with a glowing infant star at its center, hidden from direct view but warming its surroundings. It is within these accretion disks that our 17th fact resides, the birth of planets. The same cosmic dust we encountered earlier now begins to stick together. Tiny ice-covered grains gently bump into one another, clinging together through electrostatic forces. Over thousands of years, they form pebbles, then rocks, then boulders, and eventually planetesimals, the building blocks of planets. Our own Earth began its life as dust in just such a disk around our young sun 4.5 billion years ago. These stellar nurseries are also planetary nurseries. Our 18th fact is about the moment of ignition. After millions of years of gathering mass, the pressure and temperature at the core of the protostar becomes so immense that a miraculous event occurs. Nuclear fusion begins. Hydrogen atoms are forced together to create helium, releasing a tremendous amount of energy. This is the moment a star is truly born. A wave of light and heat pushes outward, and for the first time, the star begins to shine on its own. The warmth you feel from our sun had its origin in a moment just like this, deep in a dusty cloud long, long ago. Once a star ignites, its story is not over. Our 19th fact is that young stars are often incredibly active and unruly. They can produce powerful jets of gas that shoot out from their poles at hundreds of thousands of miles per hour. These jets slam into the surrounding nebula, creating beautiful glowing structures called Herbig-Haro objects. They are like the birth announcement of a new star, a visible sign of its energetic arrival, clearing away the dusty cocoon from which it emerged. Let us look back at the Orion Nebula for our 20th fact.
At its heart lies a small group of incredibly bright, hot young stars known as the trapezium cluster. These stars are cosmic newborns, only a few 100,000 years old. They are the engine that powers the entire nebula. Their intense ultraviolet radiation is what causes the surrounding hydrogen gas to glow that brilliant shade of red, a process we will explore more deeply very soon. They are sculpting the cloud from which they were born, carving out a vast cavern of light. 21. Not all of the collapsing cloud makes it into the star. A significant portion is either incorporated into the accretion disk to form planets, or is blown away once the star ignites. The efficiency of star formation is surprisingly low. Often only about 10% of the gas and dust in a collapsing core will actually become part of the final star. The rest is returned to the interstellar medium, ready to be part of the next generation of star formation. The universe is wonderfully patient and never wastes a thing. Our 22nd fact concerns the variety of stars born in these nurseries. Within a single cloud like Orion, stars of all different masses are formed. A few will be massive, hot blue stars that will burn through their fuel in just a few million years. Many more will be medium-sized yellow stars like our Sun, with lifetimes of billions of years. And the vast majority will be small, cool red dwarf stars which will sip their fuel so slowly they can live for trillions of years. The stellar nursery is a diverse and varied family. What does it sound like inside a stellar nursery? Our 23rd fact is about the silence. Despite the immense energy and activity, the gas and dust are so thin that sound as we know it cannot travel.
The birth of a star, the supersonic jets, the swirling disks, all of this happens in a profound, absolute quiet. The story of creation is written in light and motion, not in sound. It is a silent symphony of gravity and light. 24. We can see these stellar nurseries because the young, hot stars within them act like cosmic light bulbs. They illuminate the surrounding gas and dust, making it visible to our telescopes. Without these infant stars, the vast molecular clouds would remain dark and invisible, their secrets hidden from our view. The first children of the cloud are the ones that reveal its beauty to the rest of the universe. And our 25th fact about these beautiful places, they will not last forever. Over millions of years, the intense radiation and powerful winds from the newly formed stars will gradually blow away the remaining gas and dust. The nursery will disperse, leaving behind a young, brilliant star cluster drifting together through the galaxy. The cloud will be gone, its substance transformed into a family of shining stars, a testament to the creative power of the cosmos, a cycle of dust to stars completed once more. As we drift away from the warm cradle of the Orion Nebula, we notice the incredible range of colors painted across the cosmic canvas. These are not random hues. Each color tells a story of physics, of energy, and of chemistry. This brings us to the palette of the cosmos. Our 26th fact explains the most common color we see in star-forming regions, a vibrant glowing red or pink. This color comes from the most abundant element in the universe, hydrogen. Young massive stars pour out immense amounts of ultraviolet radiation. This high-energy light strikes the hydrogen atoms in the surrounding gas, stripping away their single electron in a process called ionization. But the electron doesn't stay away for long. It is quickly recaptured by the hydrogen nucleus, and as it cascades back down through its energy levels, it emits light at very specific wavelengths. The most prominent of these is a deep red light known as hydrogen alpha, or H-alpha. This is why nebulas like Orion and the Lagoon Nebula are bathed in a soft, rosy glow. They are, in essence, colossal neon signs, with hydrogen gas providing the light. But what about the brilliant blues we often see? This leads us to our 27th fact, which concerns a different kind of nebula, the reflection nebula. A perfect example is the haze surrounding the Pleiades star cluster, also known as the Seven Sisters. Here, the dust is not being ionized. Instead, the starlight is simply scattering off the fine dust particles. Because the cosmic dust grains are so tiny, they are much more efficient at scattering shorter, bluer wavelengths of light than longer, redder ones.
It is the very same principle, Rayleigh scattering, that makes our own sky blue. The blue light from the hot young stars of the Pleiades is reflected toward us by the dust, creating a beautiful, ethereal blue haze that looks like a celestial fog. Let's combine these ideas for our 28th fact. Many nebulas are a blend of both types. The famous Trifid Nebula, for instance, showcases this beautifully. One part of the cloud is an emission nebula, glowing a bright pink from ionized hydrogen. Right next to it is a reflection nebula, reflecting the light of a nearby star with a brilliant blue hue. And crisscrossing both are dark lanes of obscuring dust. Seeing them together allows us to witness different cosmic processes happening side by side. Our 29th fact delves into other colors. While red from hydrogen is the most common, other elements add their own unique signatures to the cosmic palette. Ionized oxygen, for example, glows with a distinct greenish-blue light. Sulfur, when ionized, emits a deep red, a different shade from the hydrogen. By using special filters on their telescopes, astronomers can isolate these different colors, creating stunning composite images that are not only beautiful, but also function as chemical maps of the nebula, showing where each element is most abundant. Imagine this for our 30th fact, the synesthesia of space. If we could assign a sound to each color, the dominant red of hydrogen might be a deep, constant hum, the foundation of the cosmic orchestra. The greenish hue of oxygen might be a higher, clearer note, like a bell, ringing in the hottest, most energetic regions near the stars. And the deep red of sulfur could be a low, resonant tone. A composite image of a nebula is, in this sense, a visual chord, a harmony of elements singing in light. 31. The color of a nebula can tell us about the age and temperature of the stars within it. Only the hottest, youngest, most massive stars, the blue giants, are capable of producing enough ultraviolet radiation to ionize the surrounding gas and make it glow.
So, when you see a bright pink emission nebula, you can be certain that you are looking at a region of active, recent starbirth. The color is a direct signpost of stellar youth. Our 32nd fact is that reflection nebulas are not always blue. The color depends on two things: the color of the star providing the light and the size of the dust particles doing the scattering. If the illuminating star is a cooler, redder star, the reflected light will also have a reddish tint. And if the dust particles are larger than usual, they will scatter all colors more evenly, resulting in a whiter-looking nebula. The universe has more than one brush to paint with. Fact 33. Some nebulas change their appearance over time. A fascinating example is Hubble's Variable Nebula. This small, fan-shaped reflection nebula changes its brightness and shape over the course of just a few weeks and months. This isn't because the nebula itself is moving that fast, but because the star at its heart is surrounded by dense, clumpy clouds of dust. As these clumps orbit the star, they cast moving shadows onto the nebula, creating a celestial light show, a flickering candle in the cosmic dark. Let's think about the energy involved. Our 34th fact is that the process of making a nebula glow is incredibly inefficient. A star pours out energy in all directions, but only a fraction of that energy is the right wavelength to ionize the gas. And only a fraction of that is re-emitted as visible light that we can see. The breathtaking beauty we observe is just a tiny, visible echo of the immense power churning at the heart of the cloud. 35. The structure we see, the delicate wisps and filaments of color, are sculpted by pressure. The intense light from the central stars creates a form of pressure, radiation pressure, that pushes on the gas and dust. Alongside this, powerful stellar winds, streams of particles flowing from the stars, act like a sculptor's chisel, carving out cavities, compressing gas in some areas, and creating the intricate, lace-like patterns that make nebulas so captivating. They are monuments shaped by light itself. Our 36th fact relates to infrared light. To us, the dark lanes of dust in a nebula appear empty. But if we look with an infrared telescope, which can see heat, these dark lanes often glow brightly. This is because the dust absorbs the visible and ultraviolet light from the stars and re-radiates that energy as heat in the form of infrared light. For an infrared eye, the dark parts of the nebula are some of the brightest, revealing the hidden nurseries where the next generation of stars is still forming, cloaked in their dusty blankets. And for our 37th fact on the cosmic palette, these colors are a message across time. The light from the Orion Nebula takes over 1,300 years to reach our eyes. When we look at its rosy glow, we are seeing the nebula as it was during the Middle Ages on Earth. We are looking at a postcard from the distant past. The light acts like a time machine, carrying the story of the elements, the stars, and the ongoing act of creation, delivered to our eyes after a journey of millennia through the silent, empty spaces. Now, let us turn our attention from the brilliant fields of color to the spaces in between, to the shadows. Sometimes the most profound sights in the cosmos are not things that shine, but things that block the light. We are drifting now toward the dark nebulas, the silent silhouettes of the galaxy. Our 38th fact is that dark nebulas are not holes in the universe. They are not empty patches where the stars have gone out. On the contrary, they are some of the densest, most concentrated clouds of interstellar gas and cosmic dust. They are so thick that they completely block the light from any stars or glowing nebulas that lie behind them, creating the illusion of a starless void. They are shadows cast on a cosmic scale. Let's visit the most iconic of these, the Horsehead Nebula, for our 39th fact. This famous shape is not a structure in itself, but a silhouette. It is part of a much larger dark cloud of cold gas and dust known as Barnard 33. The distinctive shape of a horse's head is simply a dense tendril of this dark material, visible because it happens to be positioned in front of a bright pink emission nebula, IC 434. The red glow provides the perfect backlight, like a cosmic theater screen, allowing us to see the shadow in stark relief. How dense are these clouds? Our 40th fact provides some perspective. While we call them dense, that is only by cosmic standards. The density of a dark nebula is still far, far less than the best vacuum we can create in a laboratory on Earth. A cubic centimeter of the Horsehead Nebula might contain only a few thousand molecules. A cubic centimeter of the air you are breathing right now contains billions of trillions of molecules.
Yet, over the vast distances of space, light years thick, this incredibly thin concentration of dust is enough to be completely opaque. Our 41st fact is that these dark clouds are the very first stage of star formation. They are the cold, undisturbed reservoirs of material before the process of collapse has truly begun. They are the future stellar nurseries, currently in a state of deep, cold hibernation. The darkness is a sign of immense potential, a quiet promise of future light. Let's explore another beautiful example with our 42nd fact, the Coal Sack Nebula. This is one of the most prominent dark nebulas in the sky, easily visible to the naked eye from the southern hemisphere. It looks like a great, dark patch against the bright river of the Milky Way. To ancient peoples, it was not an object, but an absence, a window into the void. It is a wonderful reminder that sometimes the most noticeable thing in a bright field is the shadow. These clouds are not just made of simple molecules. Our 43rd fact is that within the deep, shielded interiors of these dark nebulas, complex chemistry can occur. The dust grains act as tiny catalysts, providing a surface where atoms can meet and combine. Astronomers have detected over 100 different types of molecules in these clouds, including simple alcohols, sugars, and the building blocks of amino acids. These dark, cold places are cosmic laboratories, quietly creating the molecular ingredients for life long before the stars and planets are even formed. The shape of these dark nebulas is our 44th fact. They are not uniform, spherical clouds. They are clumpy, filamentary, and irregular. This intricate, stringy structure is the result of a delicate dance between gravity, which tries to pull the cloud together, and the subtle magnetic fields that thread through the gas, providing a kind of support. The shapes we see are a snapshot of this cosmic tension, a frozen moment in the slow-motion battle between collapse and stability. Let's consider the feeling of these places for our 45th fact. If you could float inside a dark nebula, the experience would be one of profound isolation and silence. You would be surrounded by an almost total blackness, a darkness more complete than any night on Earth. The stars would be gone, blotted out by the thick dust. The only light might be a faint, infrared glow from the dust itself, a warmth you could not see but only feel. It is the ultimate sensory deprivation chamber, a place of perfect, velvety stillness. 46. How do we study what's inside them if we can't see through them? Astronomers use radio waves. The cold hydrogen gas and carbon monoxide molecules within these clouds emit faint signals at radio wavelengths. This radiation passes right through the dust that blocks visible light. By using radio telescopes, we can map the structure, density, and motion of the gas deep inside these dark clouds, piercing the veil and watching the very earliest stages of star formation unfold. Our 47th fact reveals that even dark nebulas can have a touch of reflected light. Sometimes, if a star is located near the edge of a dark cloud, it can illuminate the very surface of the dust. This creates a soft, brownish glow like a dimly lit fog. These are sometimes called brown nebulas, and they show us the boundary, the transition from the dark heart of the cloud to the starlit space beyond. Fact 48. These clouds are temporary. Just like the glowing nebulas, they will eventually be consumed and dispersed by the very stars they create. As protostars form within them, their winds and jets will begin to carve out pockets and holes. When the most massive stars ignite, their intense radiation will blow the remaining dust away, and the darkness will give way to a brilliant new star cluster. The shadow exists only to give birth to the light. Think of the scale for our 49th fact. Some of these dark cloud complexes are enormous, stretching for hundreds of light years across the galaxy. The Great Rift, which creates the dark lane running down the center of the Milky Way's band in our summer sky, is a series of overlapping dark nebulas, a vast wall of dust in our local spiral arm that hides the brilliant galactic center from our view. We live in a galaxy filled with these cosmic shadows. And our 50th fact about these shadows in the starlight is a comforting one. The darkness is not an ending. It is a beginning. It is the quiet, fertile ground from which new light will spring. The dust that blocks the view of the distant stars is the very same dust that will one day build new stars, new planets, and new possibilities. The silence and the shadow are simply the universe taking a slow, deep breath before the next act of creation begins. We now leave the comforting darkness of the cosmic shadows and turn our attention to the final act in the lives of many stars.
Not all stellar endings are the same. Some are quiet, and some are thunderous. We begin with the most common, a graceful and beautiful farewell that awaits stars much like our own sun. We are drifting toward the echoes of a life, the planetary nebulas. Our 51st fact sets the stage for this gentle conclusion. When a star like our Sun, after billions of years of steady shining, finally exhausts the hydrogen fuel in its core, it does not explode. Instead, it begins a slow, magnificent transformation. It swells into a red giant, its outer layers expanding and cooling. Then, over thousands of years, in a series of gentle pulses, it pushes these outer layers away, releasing them into space like a slow, cosmic sigh. This leads us to our 52nd fact, which is about their beautiful but misleading name. When early astronomers like William Herschel first observed these objects in the 18th century through their small telescopes, they saw faint, round, glowing disks. They reminded them of the newly discovered planet Uranus, and so they called them planetary nebulas. The name has stayed with us, a poetic piece of history, even though we now know they have nothing at all to do with planets. They are the final, fleeting artworks of a dying star. Let us imagine this process with our 53rd fact. Imagine the star as a great beating heart. As it ages, its rhythm becomes unstable. With each pulse, a shell of gas, rich with elements created over a billion-year lifetime, expands outward into the void. A new pulse sends another shell, moving faster, which can crash into the first. This cosmic choreography, this interplay of expanding shells of gas, is what begins to build the intricate and delicate structures we observe. At the center of it all lies our 54th fact,
the remnant of the star itself. Once the outer layers have drifted away, the star's core is revealed. It is now a tiny, incredibly hot and dense object called a white dwarf. A white dwarf may have the mass of our Sun compressed into a volume the size of the Earth. It is this intensely hot stellar core that illuminates the nebula. It is the candle that lights up the beautiful shroud. The breathtaking colors of a planetary nebula are the subject of our 55th fact. Just as we saw in the stellar nurseries, the intense ultraviolet radiation from the central white dwarf ionizes the expanding clouds of gas, causing them to glow. The specific colors are the chemical fingerprints of the star's life. A soft greenish-blue hue indicates the presence of ionized oxygen, while reds and pinks often come from hydrogen and nitrogen. Each planetary nebula is a rainbow of its own history. Perhaps the most wondrous aspect of these objects, and our 56th fact, is their staggering variety of shapes. For a long time, we imagined them as simple, spherical bubbles. But with powerful telescopes, we have discovered an entire cosmic zoo of forms. Some are shaped like hourglasses, some like butterflies with delicate wings stretching for light years. Others look like intricate geometric patterns or ethereal cosmic jets. It's believed these complex shapes are sculpted by the star's magnetic field, its rotation, or perhaps the gravitational pull of an unseen companion star, which acts like a cosmic potter's hand shaping the outflowing gas. Let us visit one of the most famous of these, the Ring Nebula, for our 57th fact. From our vantage point on Earth, it looks like a perfect glowing smoke ring, a celestial Cheerio adrift in the constellation Lyra. The ring we see is actually the edge of a barrel-shaped cloud of gas, tilted so that we are looking down its length. The different colors, from the red inner ring of nitrogen to the green outer ring of oxygen, tell us about the composition of the gas and its distance from the hot star center. It is a portrait of a star's atmosphere turned inside out for all the universe to see. Now we drift toward another, the Helix Nebula, the subject of our 58th fact. Lying much closer to us, at a distance of about 700 light-years, it is so large in the sky that it appears as big as the full moon. Its appearance has earned it the nickname the Eye of God. It truly looks like a giant cosmic eye staring back at us from the depths of space. Looking closely, we can see thousands of tiny, dense clumps of gas within the nebula, each larger than our own solar system. They look like comets, with bright heads and long faint tails pointing away from the central star, a testament to the powerful radiation that is evaporating them. Our 59th fact is about their ephemeral nature. For all their beauty, planetary nebulas are one of the most short-lived phenomena in the cosmos. They are visible for only about 10,000 years, a mere blink of an eye in cosmic time. After this, the central white dwarf will have cooled, and the expanding gas will have become so thin and diffuse that it no longer glows.
It simply fades away, becoming an invisible part of the interstellar medium. We are fortunate to live in a time when we can witness these brief, final masterpieces. But their fading is not an end. It is a vital contribution. Our 60th fact is that planetary nebulas are a crucial part of the cycle of cosmic recycling. Stars are factories for heavier elements. Over its long life, a star like our Sun fuses hydrogen into helium and later helium into carbon and nitrogen. When the star sheds its outer layers, it releases these newly forged elements back into the galaxy. This is where a significant portion of the carbon and nitrogen in the universe comes from. Think about that for a moment. The carbon atoms that form the basis of all known life, the nitrogen in our DNA, were created deep inside stars and then gently released into space through these beautiful expanding nebulas. We are, in a very real sense, made from the ashes of these gentle stellar endings. This is our 61st fact. And for our 62nd fact, we bring this journey close to home. This gentle, beautiful process is the destiny of our own Sun. But there is no need to worry. This will not happen for another 5 billion years. When it does, our sun will expand into a red giant, and then it will release its own atmosphere into space, creating a magnificent planetary nebula for future astronomers in distant star systems to observe. It will be our sun's final gift to the cosmos, a glowing echo of the life that once thrived around it, its elements sent forth to seed new stars and new worlds. From the gentle exhale of a sun-like star, we now travel to a far more dramatic and powerful conclusion. We journey to witness the cataclysmic canvas painted by the universe's most energetic events. We are now among the supernova remnants. Our 63rd fact establishes the difference. Stars that are born with more than 8 times the mass of our sun live fast and expire young. At the end of their lives, they do not fade away. They go out in a blaze of glory. The core of the star collapses under its own immense gravity, triggering a titanic explosion known as a supernova. This is the most powerful explosion the universe knows, and for a few weeks, a single supernova can outshine its entire home galaxy of billions of stars. So what remains after such a cataclysm? This is our 64th fact. A supernova remnant is the structure resulting from this explosion. It is an expanding, glowing cloud of debris, the star's own material, hurled into space at tremendous speeds by the blast wave. At the very center of this expanding chaos, something extraordinary is left behind. Either an incredibly dense object called a neutron star, or, if the original star was massive enough, a black hole. Let us visit the most famous of all supernova remnants, the Crab Nebula, for our 65th fact. This nebula is the aftermath of an explosion that was witnessed here on Earth. In the year 1054, Chinese astronomers and others around the world recorded the appearance of a brilliant guest star in the sky. It was so bright it was visible during the daytime for over 3 weeks. The light from that ancient explosion, after traveling for 6,500 years, had finally reached Earth. The Crab Nebula is the beautiful, expanding wreckage of that very event. At the heart of the Crab Nebula is its engine, the subject of our 66th fact. Here lies the collapsed core of the original star, a pulsar. This is a neutron star, a city-side sphere of matter so dense that a single spoonful would weigh as much as a mountain. And it is spinning, incredibly fast, 30 times every second. With each rotation, it sweeps beams of energy toward us like a cosmic lighthouse. It is the energy from this spinning pulsar that lights up the nebula from within, creating its ghostly, synchronized glow. This entire structure is still expanding from the initial explosion. Our 67th fact is about its speed. The filaments of the Crab Nebula are rushing outward at about 1,500 kilometers per second. That is over 3 million miles per hour. This speed is so great that when we compare photographs of the nebula taken just a few years apart, we can actually see the expansion. We are watching the ghost of an explosion still unfolding before our very eyes nearly 1,000 years after it began. Let's look closely at its structure for our 68th fact. The Crab Nebula is not a uniform cloud. It is a mesmerizing and complex tangle of filaments. The delicate, branching, reddish-orange filaments are composed of hydrogen and helium, remnants of the star's original outer layers. But bathing the entire interior is a mysterious, eerie blue glow. This is not from glowing gas. This is something called synchrotron radiation, emitted by extremely high-energy electrons as they spiral through the pulsar's powerful magnetic fields. This entire structure is still expanding from the initial explosion. Our 67th fact is about its speed. The filaments of the Crab Nebula are rushing outward at about 1,500 kilometers per second. That is over 3 million miles per hour. This speed is so great that when we compare photographs of the nebula taken just a few years apart, we can actually see the expansion. We are watching the ghost of an explosion still unfolding before our very eyes nearly 1,000 years after it began.
Let's look closely at its structure for our 68th fact. The Crab Nebula is not a uniform cloud. It is a mesmerizing and complex tangle of filaments. The delicate, branching reddish-orange filaments are composed of hydrogen and helium, remnants of the star's original outer layers. But bathing the entire interior is a mysterious, eerie blue glow. This is not from glowing gas. This is something called synchrotron radiation, emitted by extremely high-energy electrons as they spiral through the pulsar's powerful magnetic fields. This entire structure is still expanding from the initial explosion. Our 67th fact is about its speed. The filaments of the Crab Nebula are rushing outward at about 1,500 kilometers per second. That is over 3 million miles per hour. This speed is so great that when we compare photographs of the nebula taken just a few years apart, we can actually see the expansion. We are watching the ghost of an explosion still unfolding before our very eyes nearly 1,000 years after it began. Let's look closely at its structure for our 68th fact. The Crab Nebula is not a uniform cloud. It is a mesmerizing and complex tangle of filaments. The delicate, branching reddish-orange filaments are composed of hydrogen and helium, remnants of the star's original outer layers. But bathing the entire interior is a mysterious, eerie blue glow. This is not from glowing gas. This is something called synchrotron radiation, emitted by extremely high-energy electrons as they spiral through the pulsar's powerful magnetic fields.
It is a visible sign of the immense, invisible power at the nebula's heart. Supernovas are the universe's primary forges for heavy elements. This is our 69th fact. While smaller stars create elements up to carbon and oxygen, it takes the incredible heat and pressure of a supernova explosion to create heavier elements like gold, silver, platinum, and uranium. Every piece of gold jewelry, every silver coin was forged in the heart of a cataclysmic stellar explosion billions of years ago and then scattered across the galaxy. Let us now drift toward another, very different-looking supernova remnant, the Veil Nebula, for our 70th fact. Unlike the dense, filled-in shape of the crab, the veil is a delicate, intricate, lace-like structure of glowing gas, spread across a huge area of the sky. It is the remnant of a supernova that exploded around 8,000 years ago. The blast wave from that explosion is still traveling through the interstellar medium, sweeping up and heating the gas it encounters, causing it to glow in these beautiful, thin sheets and filaments, like a cosmic ripple in a pond. The colors of the Veil Nebula tell a story, which is our 71st fact. The different colors correspond to different gases being excited by the high-speed shockwave. The bright red or pink filaments are from glowing hydrogen. The blues and greens come from oxygen atoms that have had not one, but 2 electrons stripped away by the energy of the shock, a sign of a very high-energy collision. We are not just seeing the debris of the star, we are seeing the interstellar medium itself being lit up by the passing ghost of the explosion. Supernova remnants can also emit X-rays. This is our 72nd fact. The gas in a supernova remnant is heated to millions of degrees by the shockwave. This gas is so hot that it shines brightly in X-ray light, which is invisible to our eyes. When we look at a remnant like Cassiopeia A with an X-ray telescope, we see a brilliant, glowing ball of superheated gas, allowing us to map out the different elements blasted from the star. We can see where the silicon, sulfur, and iron are, tracking how the star was layered before it was torn apart. Our 73rd fact is about time. Even these titanic structures are temporary. Over hundreds of thousands of years, a supernova remnant will continue to expand and cool. Its shock wave will slow down as it sweeps up more and more interstellar material. Eventually, it will merge completely with the surrounding gas and dust of the galaxy, becoming indistinguishable. But its contribution is permanent. It will have enriched that region of space with heavy elements and triggered new waves of star formation in the clouds it compressed. The blast from a supernova has a profound impact on its galactic neighborhood. This is our 74th fact.
The powerful shock wave expands outwards, compressing the clouds of gas and dust it encounters. This compression can be the trigger that starts the collapse of these clouds, initiating the birth of a new generation of stars and planets. The death of one massive star can be the direct cause of the birth of hundreds of smaller ones. The cycle of creation and destruction is intimately linked. And for our 75th fact on this cataclysmic canvas, let us consider the sound. Like the stellar nurseries, these events, the most powerful explosions in the universe, happen in the perfect silence of the vacuum. There is no sound wave, no thunderous roar. The story of this immense power is told only in light, in visible light, in X-rays, in radio waves. It is a silent spectacle of energy transforming into static, intricate beauty. A beautiful scar left on the fabric of space-time, a permanent reminder of a life lived brilliantly and a death that seeded the future. We have felt the warmth of newborn stars and witnessed the grand finales of their lives. Now, let us journey to a place of profound quiet and stillness. We are seeking out the coldest known places in the universe, where the laws of physics approach their absolute limit. Our 76th fact brings us to a remarkable object known as the Boomerang Nebula. This is, as far as we have measured, the coldest natural place in the universe. Located about 5,000 light-years away, this young planetary nebula has a temperature of just 1 degree Kelvin. That is 1 degree above absolute zero, the theoretical point at which all atomic motion ceases. It is colder than the faint, background microwave radiation that fills all of space, which is itself a chilly 2.7 degrees Kelvin. How can a place be colder than the background temperature of the universe itself? This is our 77th fact. The Boomerang Nebula is actively cooling itself. At its center is a dying star that is shedding its mass, but it is doing so incredibly rapidly, about 100 times faster than other similar stars.
The gas is being ejected at very high speeds, over 500,000 kilometers per hour. This rapid expansion acts like a cosmic refrigerator. Just as expanding gas in a spray can feels cold, this gas is cooling dramatically as it expands into the vacuum of space, causing its temperature to plummet. Our 78th fact is about its appearance. Early ground-based telescope images showed a lumpy, boomerang-like shape, which is how it got its name. But higher-resolution images from the Hubble Space Telescope revealed a more intricate, hourglass or bow tie shape. It is a beautiful, ghostly nebula, and its extreme cold is a very recent and short-lived phase of its evolution. As the central star continues to evolve and heat up, it will eventually warm the nebula, and its unique status as the coldest place will be lost. This deep cold is not just a curiosity, it allows for unique chemistry. Our 79th fact is that in the ultra-cold environments of molecular clouds and nebulas like the Boomerang, dust grains act as tiny frozen laboratories. Molecules and atoms that wander through space can stick to the icy surfaces of these dust grains. Held in place by the cold, they are more likely to meet other atoms and react, forming more complex molecules. This process, known as grain surface chemistry, is thought to be essential for building the complex organic molecules that are the precursors to life. The deepest cold is a place of quiet creation. Our 80th fact concerns the molecular clouds we visited earlier, the birthplaces of stars. These vast, dark clouds are also among the coldest places in the universe. Typically, their temperatures hover around 10 to 20 degrees Kelvin. It is this extreme cold that allows gravity to do its work. If the gas were warmer, the individual atoms would be moving too quickly, creating an outward pressure that would resist gravitational collapse. The cold stills the gas, quieting it, and allows gravity's gentle, persistent pull to gather it together to form new stars. The cold is a necessary condition for warmth to be born. What does it mean for gas to freeze in a vacuum? Our 81st fact addresses this. It's not like watching water turn to ice. Instead, in the near-perfect vacuum of space, individual gas molecules will simply deposit themselves onto a cold surface, a process called deposition. They go directly from a gas to a solid.
This is how the icy mantles form on cosmic dust grains. Molecules of water, carbon monoxide, and ammonia flying through the cloud will eventually strike a dust grain, lose their energy, and become frozen to its surface, building up a frosty layer molecule by molecule over millions of years. The absolute stillness of these cold places is our 82nd fact. At 1 degree Kelvin, the atoms and molecules in the Boomerang Nebula are moving incredibly slowly. They are almost, but not quite, at a complete standstill. This is a state of matter far beyond our everyday experience. If you could be there, you would feel a cold so profound that it seems to slow down time itself. It is a deep, preserving cold, a form of perfect stasis and rest, where the universe is holding its breath. The coldest temperatures allow us to see the universe in a different light, literally. Our 83rd fact is that astronomers use telescopes that can detect very long wavelengths of light, such as sub-millimeter waves and radio waves, to study these frigid regions. Cold objects do not glow in visible light, but they do emit a faint glow at these longer wavelengths. Telescopes like ALMA, the Atacama Large Millimeter Submillimeter Array, can peer into the cold, dark hearts of molecular clouds and see the faint heat signatures of dust and gas, revealing the hidden processes of star and planet formation that are completely invisible to optical telescopes. Let's think about the cosmic microwave background again for our 84th fact. This faint radiation, the afterglow of the Big Bang, sets a baseline temperature for the universe. Almost everywhere we look, the temperature of empty space is 2.7 Kelvin. The fact that the Boomerang Nebula is colder than this background means it is a very special, isolated system that is losing heat faster than it can absorb it from the rest of the universe. It is a small pocket of exceptional cold in a universe that is already incredibly vast and cool. Our 85th fact is that even within our own solar system, there are places of extreme cold. In craters near the poles of our moon, in regions that are permanently shadowed from the sun, temperatures can drop to around 40 Kelvin. While not as cold as the Boomerang Nebula, these are some of the coldest spots in our solar system, cold enough for water ice to remain stable for billions of years. These frozen reservoirs are like time capsules from the early solar system. The feeling of absolute zero is our 86th fact.
It is a fundamental limit of the universe. According to the laws of thermodynamics, it is impossible to cool any system down to exactly 0 Kelvin. You can get incredibly close, but you can never quite reach it. This ultimate cold represents a state of perfect order, of minimum possible energy. The Boomerang Nebula, at 1 degree Kelvin, is taking us to the very edge of what is possible in nature. And for our 87th fact about the coldest places, let us embrace the quiet. The cold of deep space is not harsh or aggressive. It is a deep, calming stillness. It is the absence of the frantic energy that defines our world. It is a state of perfect preservation, where the ingredients of the universe lie dormant, waiting patiently for the right moment to awaken. In this profound cold, there is a profound peace, a sense of timelessness, and the quiet potential for all the warmth and light that is yet to come. It is the universe in a state of deep and restful meditation. Throughout our journey, we have traveled as silent observers, witnessing the grand life cycles of the cosmos. We have drifted through the nurseries of creation and the beautiful remnants of stellar lives. And now, for this final chapter of our exploration, we turn our gaze not outward, but inward. We come to the most profound and intimate fact of all, the deep and unbreakable link between the distant, glowing nebulas and our very own existence. We come to understand that we are stardust. This brings us to our 88th fact, a truth so simple and yet so powerful, it has the ability to change the way we see ourselves forever. The atoms that make up your body, the carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, were not created here on Earth. They were forged in the fiery hearts of stars, scattered across the galaxy in beautiful, expanding nebulas, and then gathered together billions of years later to form our planet, our ecosystem, and ultimately, you.
You are not separate from the cosmos. You are a living, breathing, thinking piece of it. To understand this connection, we must go back to the very beginning. Our 89th fact is about the universe's starting materials. In the first few moments after the Big Bang, the universe was an incredibly hot, dense soup of energy. As it expanded and cooled, this energy coalesced into the first and simplest atoms: hydrogen, a small amount of helium, and trace amounts of lithium. And that was it. The primordial universe was chemically very simple. Every other element, every building block of the complex world we know, had to be created. The universe, in its infancy, had to learn how to build. The factories for this cosmic construction are the stars themselves. Our 90th fact focuses on the element that is the very backbone of life as we know it: carbon. The early universe had no carbon. Carbon is made inside stars of a certain mass, like our Sun, during their later stages of life. Deep in the stellar core, where temperatures reach hundreds of millions of degrees, helium atoms are fused together. In a delicate three-step dance called the triple alpha process, 3 helium nuclei combine to form one stable nucleus of carbon. For billions of years, stars have been performing this cosmic alchemy, patiently turning the simplest gas into the fundamental building block of life. And when these stars reach the end of their lives, they gently puff their newly made carbon out into the galaxy in the beautiful planetary nebulas we have visited. So the very carbon that structures your DNA, that forms the architecture of every cell in your body, once resided in the heart of a long-expired star. It is an inheritance from a sun that is no more. Now let's consider the air you are breathing. With every gentle inhale and exhale, you are taking in oxygen. Our 91st fact is that this life-giving oxygen also has a stellar origin. It is created in stars more massive than our Sun. After these stars have converted their helium into carbon, their cores become even hotter and denser, allowing for the fusion of heavier elements. A carbon nucleus fuses with another helium nucleus to become an oxygen atom. When these massive stars finally exhaust their fuel, they explode as supernovas, blasting their oxygen and other precious elements out into the interstellar medium at incredible speeds. The oxygen that fills your lungs right now, the oxygen that bonds with hydrogen to create the water that makes up most of your body, was born in the heart of a cataclysmic stellar explosion, an event of unimaginable power that took place billions of years ago, hundreds of light years away. And then there is the iron. Our 92nd fact is perhaps the most tangible and powerful connection of all. In the center of your red blood cells is a molecule called hemoglobin, and at the heart of that molecule is a single atom of iron.
It is this iron atom that captures the oxygen in your lungs and carries it to every part of your body. This element, so crucial for our life, can only be created in the most extreme conditions the universe has to offer. The final, fleeting moments of a massive star's life, just before and during a supernova explosion. The intense heat and pressure of the collapsing core is the only furnace hot enough to forge iron. And so, the iron in your blood, the very element that gives it its red color and its ability to carry life, is the direct product of the most violent and spectacular event in the cosmos. Feel the gentle pulse of your own heartbeat. With each beat, you are feeling the echo of ancient supernovas. You are a living vessel of their fiery legacy. This constant creation and dispersal of elements is our 93rd fact, the great cycle of cosmic recycling. The universe is not a static place. It is a dynamic, living system. Stars are born from vast clouds of gas and dust. They live for millions or billions of years, creating heavier elements in their cores. Then they die. Smaller stars release their elements gently in planetary nebulas. Massive stars release theirs violently in supernovas. This stardust, this precious ash of carbon, oxygen, iron, and more, is swept into the vast dark clouds of the interstellar medium. The clouds become enriched, their chemical composition growing more and more complex with each passing generation of stars. It is from these enriched clouds that new solar systems are born. This is our 94th fact. Our own solar system, our Sun, our Earth, and the other planets, formed about 4.5 billion years ago from a cloud that had been seeded by many previous generations of stars. The Earth did not form from pure hydrogen and helium. It formed from a rich mixture of all the elements, a cosmic inheritance that made the formation of rocky planets and, eventually, life possible. The ground beneath you, the mountains, the oceans, the air, it is all recycled stardust. We are living on the remnants of stars. And it's not just carbon, oxygen, and iron. Our 95th fact is a quiet meditation on the other stellar ingredients within you. The calcium that gives your bones their strength was forged in massive stars. The potassium and sodium that allow your nerves to send signals, enabling your very thoughts and feelings, were created in dying stars and scattered by supernovas. The zinc, the copper, the selenium, trace elements essential for life, all have their origins in these distant stellar crucibles. You are a walking, talking collection of elements, a chemical symphony whose notes were composed in the hearts of 1,000 different stars, across billions of years and vast expanses of the galaxy. How can we be so certain of this cosmic heritage? Our 96th fact is about the elegant science of spectroscopy. When light from a distant star or nebula passes through a prism, it splits into a rainbow of colors, a spectrum. But this spectrum is not perfectly smooth. It is crossed by dark or bright lines. These lines are like a cosmic barcode. Each element, when heated, emits or absorbs light at very specific, unique wavelengths. By analyzing the spectrum of a star, astronomers can read its barcode and determine exactly which elements it is made of, and in what quantities. And what we have found, with unwavering certainty, is that the elements in the stars, in the nebulas, are the very same elements we find here on Earth and in ourselves. The chemistry of the cosmos and the chemistry of life are one and the same. Let us reflect on the immense timescale of this journey, which is our 97th fact. The atoms that constitute your body are ancient, many of them billions of years old. They have traveled across the galaxy, participating in epic cycles of birth and death. An atom of carbon in your fingertip might have been born in a star in one spiral arm of the Milky Way, while an atom of iron in your blood could have come from a supernova in a completely different region. You are an assembly of wanderers, a temporary gathering of stardust that has been on an incredible journey to get here. You are a living museum of galactic history. This gives us a new sense of our place in the universe. Our 98th fact is about our galactic lineage. We often think of our ancestry in terms of generations of people, stretching back hundreds or thousands of years. But our true ancestry is far grander. It stretches back billions of years, to the first generation of stars that seeded our galaxy with heavy elements. We are connected not just to every living thing on Earth, but to every star that has ever shone. Every glowing nebula we have visited tonight is a part of our extended family history, a monument to the ancestors of our very atoms. This is a profound sense of belonging, a unity that transcends all boundaries.
Now, bring your awareness inward, to the quiet, steady warmth of your own body. Our 99th fact is a sensory one. The energy that animates you, the metabolic processes that keep you warm, are all chemical reactions. But the very atoms participating in these reactions were created by nuclear reactions, by the fusion fires at the hearts of stars. The warmth you feel is, in a very real and physical sense, a slow, gentle, biological echo of the stellar fires that gave you form. Feel that internal warmth not just as a sign of life, but as a direct connection to the distant, shining stars. The fire of the cosmos is within you. And so we arrive at our 100th and final fact. The universe, for billions of years, was a place of incredible beauty and complexity, but it was all unobserved. There was no one and nothing to witness the glowing nebulas, the silent birth of stars, the graceful dance of galaxies. Then, on this small planet, from the recycled ashes of countless stars, life emerged. And eventually, a part of that life, humanity, developed the ability to look up, to wonder, to understand.
We are, as the great astronomer Carl Sagan said, a way for the cosmos to know itself. The stardust has awakened. The journey of these atoms has led to consciousness. And in moments like this, as you lie here peacefully contemplating the stars, the universe is contemplating itself, through you. This is not just a poetic idea. It is the literal truth. You are the universe made manifest, and you are beautiful. Our journey through the cosmos is drawn to a close. We have traveled so far, across light years and eons, from the tiniest grains of cosmic dust to the grand architecture of the galaxy. We have witnessed the birth of stars in their warm, dusty nurseries. We have seen the vibrant palette of the universe, painted with the light of glowing gas. We have rested in the deep, comforting shadows of the dark nebulas, and we have honored the lives of stars, from their gentle, beautiful goodbyes to their spectacular, world-building finales. We have felt the profound stillness of the coldest places in the universe, and we have discovered the unbreakable connection that ties us to it all. Now it is time to begin the journey home. Imagine yourself drifting, slowly, weightlessly, away from the starlit tapestries we have explored. The brilliant colors of the nebulas begin to soften, their light fading into the gentle velvet darkness. The vast cosmic clouds recede, becoming once again faint, shimmering jewels on the black canvas of the night. The grand scale of the galaxy shrinks, the spiral arms pulling back into a single, beautiful pinwheel of light, until it too is just one of many distant galaxies in the deep field of your mind's eye. You are drifting back now, back toward our own familiar corner of the universe. Past the distant orbits of the outer planets, past the majestic rings of Saturn and the great red spot of Jupiter. You see the warm, familiar light of our own sun, and the beautiful, shining crescent of our home, the Earth, growing larger to welcome you back. Feel yourself descending now, slowly and gently, through the silent upper reaches of the atmosphere. The profound blackness of space gives way to a deep, peaceful indigo, the color of twilight. You are returning to the embrace of your world, to the quiet comfort of the night. You float down effortlessly through the cool night air, back toward the soft pattern of lights below, back toward your home, through the roof, and back into your room. Feel yourself settling, ever so gently, back into your bed. Feel the comforting sensation of gravity returning, not as a weight, but a soft, reassuring anchor. You are safe. You are grounded. You are at peace. The journey is over, but the connection remains. The iron in your blood still remembers the supernova. The carbon in your bones still remembers the heart of a red giant. You are not just in the universe is in you. And as you lie here ready for sleep, you can rest in that knowledge. You can rest in the profound sense of belonging that it brings. All the facts and figures, all the names and numbers can now dissolve. Let them fade away, like distant starlight. All that matters now is the feeling of peace, the feeling of connection, the feeling of rest. Allow your breathing to be slow and deep. With every exhale, release any lingering thoughts of the day. Let them drift away into the vast, quiet spaces we have just explored. There is nothing left to do. There is nowhere else to be. There is only this moment of perfect stillness. Feel the gentle heaviness of your body as you sink deeper and deeper into comfort and relaxation. Feel your eyelids growing heavy, so very heavy. The darkness behind your eyes is as peaceful and as vast as the space between the stars. It is a comforting darkness, a place of rest and renewal. Allow yourself to drift into it. You float down effortlessly through the cool night air, back toward the soft pattern of lights below, back toward your home, through the roof, and back into your room. Feel yourself settling, ever so gently, back into your bed. Feel the comforting sensation of gravity returning, not as a weight, but a soft, reassuring anchor. You are safe, you are grounded, you are at peace. The journey is over, but the connection remains. The iron in your blood still remembers the supernova.
The carbon in your bones still remembers the heart of a red giant. You are not just in the universe is in you. And as you lie here, ready for sleep, you can rest in that knowledge. You can rest in the profound sense of belonging that it brings. All the facts and figures, all the names and numbers can now dissolve. Let them fade away like distant starlight. All that matters now is the feeling of peace, the feeling of connection, the feeling of rest. Allow your breathing to be slow and deep. With every exhale, release any lingering thoughts of the day. Let them drift away into the vast, quiet spaces we have just explored. There is nothing left to do. There is nowhere else to be. There is only this moment of perfect stillness. Feel the gentle heaviness of your body as you sink deeper and deeper into comfort and relaxation. Feel your eyelids growing heavy, so very heavy. The darkness behind your eyes is as peaceful and as vast as the space between the stars. It is a comforting darkness, a place of rest and renewal. Allow yourself to drift into it.
Allow your mind to become quiet, so very quiet. You are drifting now, drifting on a gentle, silent current toward a deep and restorative sleep. The stars are watching over you. The cosmos is within you, and all is well. Sleep now, my friend. Sleep well. Our journey through the cosmos is drawing to a close. We have traveled so far, across light years and eons, from the tiniest grains of cosmic dust to the grand architecture of the galaxy. We have witnessed the birth of stars in their warm, dusty nurseries. We have seen the vibrant palette of the universe, painted with the light of glowing gas. We have rested in the deep, comforting shadows of the dark nebulas, and we have honored the lives of stars, from their gentle, beautiful goodbyes to their spectacular, world-building finales. We have felt the profound stillness of the coldest places in the universe, and we have discovered the unbreakable connection that ties us to it all. Now it is time to begin the journey home. Imagine yourself drifting slowly, weightlessly, away from the starlit tapestries we have explored. The brilliant colors of the nebulas begin to soften, their light fading into the gentle velvet darkness. The vast cosmic clouds recede, becoming once again faint, shimmering jewels on the black canvas of the night. The grand scale of the galaxy shrinks, the spiral arms pulling back into a single, beautiful pinwheel of light, until it too is just one of many distant galaxies in the deep field of your mind's eye. You are drifting back now, back toward our own familiar corner of the universe, past the distant orbits of the outer planets, past the majestic rings of Saturn and the great red spot of Jupiter. You see the warm, familiar light of our own sun, and the beautiful, shining crescent of our home, the Earth, growing larger to welcome you back. Feel yourself descending now, slowly and gently, through the silent upper reaches of the atmosphere. The profound blackness of space gives way to a deep, peaceful indigo, the color of twilight. You are returning to the embrace of your world, to the quiet comfort of the night. You float down, effortlessly, through the cool night air, back toward the soft pattern of lights below, back toward your home, through the roof, and back into your room. Feel yourself settling, ever so gently, back into your bed. Feel the comforting sensation of gravity returning, not as a weight, but a soft, reassuring anchor. You are safe. You are grounded. You are at peace. The journey is over, but the connection remains. The iron in your blood still remembers the supernova. The carbon in your bones still remembers the heart of a red giant. You are not just in the universe is in you. And as you lie here ready for sleep, you can rest in that knowledge. You can rest in the profound sense of belonging that it brings. All the facts and figures, all the names and numbers can now dissolve. Let them fade away, like distant starlight. All that matters now is the feeling of peace, the feeling of connection, the feeling of rest. Allow your breathing to be slow and deep.
With every exhale, release any lingering thoughts of the day. Let them drift away into the vast, quiet spaces we have just explored. There is nothing left to do. There is nowhere else to be. There is only this moment of perfect stillness. Feel the gentle heaviness of your body as you sink deeper and deeper into comfort and relaxation. Feel your eyelids growing heavy, so very heavy. The darkness behind your eyes is as peaceful and as vast as the space between the stars. It is a comforting darkness, a place of rest and renewal. Allow yourself to drift into it. Allow your mind to become quiet, so very quiet. You are drifting now, drifting on a gentle, silent current toward a deep and restorative sleep. The stars are watching over you. The cosmos is within you, and all is well. Sleep now, my friend. Sleep well.